Hello friends, welcome back to the channel. And in today's video, we will learn about the best practices for sizing a JDBC connection pool. So first of all, we'll learn what is a JDBC connection pool and why is it used. Then we'll understand why deciding an optimal size for a JDBC connection pool is important. Then we will learn the key points to consider while deciding the size of a JDBC connection pool. Then we will learn the basic settings that control a JDBC connection pool. And then we will learn about the best practices for sizing a JDBC connection pool. So you see, a JDBC connection pool is a mechanism used to manage data connections efficiently. So creating a database connection involves various steps which are time consuming, such as you have to open the connection to the database, then you have to authenticate the user, then you have to create a TCP socket for communication, okay, and then sending and receiving of data happens over this socket, and then whenever you are done, you have to close this socket as well. So now repeating these steps for each user can be inefficient, especially for applications with many users. A JDBC connection pool addresses this problem by creating a pool of reusable connections at a time. When the application starts, it creates and maintains a pool of these connections, and a pool connection manager manages these connections and handles their life cycle. So whenever you need to interact with the database, the code requests for a connection, the pool manager provides one from the pool instead of creating a new one. Okay. And once this is done, the connection is returned to the pool for use when data sending and receiving is over. So this reuse of connection saves time and resources significantly, improving overall application performance. Why deciding the optimal size of a JDBC connection pool is so important? Well, deciding the optimal size of JDBC connection pool is crucial for balancing performance and resource utilization. A small pool might result in faster connection access, but could lead to delays if there are not enough connections available to satisfy all the requests. Conversely, a large pool ensures that more connections are available, reducing the time spent in queues, but potentially slowing down the access to the connection table of the database. So basically, with a small pool, we can get a faster access to the connection table of the database, thereby being able to run the queries. But our application might require more connections to satisfy the increasing request coming from the end user. So request may have to spend some time waiting in a queue to get a connection. And when using a large pool, we have more connections to fulfill our request, and requests spend less time or no time waiting in a queue. But because the number of connections are large, there is a slower access to the connection table of the database to execute the queries. So what are the key points to consider while deciding the JDBC connection pool size? So when deciding a pool size, we need to consider several factors. First, we need to evaluate the average transaction response time and the amount of time spent on database queries. Now, load testing can help determine these timings. And it is advisable to calculate the pool size, with the additional 25 buffer in the capacity in order to be able to handle unexpected load. Second, the connection pool should be capable of growing and shrinking based on the actual needs. So monitoring the system using logs and JMX surveillance can help us to adjust the pool size dynamically. Additionally, we also need to consider how many queries are executed per page load, and then the duration of each query as well. For optimal performance, we can start with a small number of connections and we can gradually increase. A pool size of 8 to 16 connections per node is, generally considered optimal to start with. So we need to adjust the idle timeout and pool's resize quantities. These are a couple of configuration properties. Idle timeout, pool resize quantity values based on the statistics that we get using our monitoring. So what are the basic settings that control the JDBC connection pool? The first is initial or minimum pool size. It is the size of the pool when it is created and its minimum allowable size. Second is maximum pool size. It is the upper limit of the pool size. Then comes pool resize quantity. It is the number of connections to be removed when the idle timeout expires. What is idle timeout? Well, if our connections are idle for a particular configured time, they are considered as candidates for removal. And the removal happens in batches. And for every resizing, the pool resize quantity that we have configured, this way the pool shrinks back or reduces in size until it reaches its initial or minimum pool size. Then comes maximum idle connections. It is the maximum number of idle connections allowed in a pool. If the number of idle connections exceeds the limit, the excess connections are closed, freeing up the additional resources. Then comes the minimum idle connection. It is the minimum number of idle connections that can be allowed to be kept in the pool. Then comes maximum wait time. It is the maximum time an application will wait for a connection to become available. And then comes validation query. It is a simple SQL query which is used to validate the connection before they are handed over to the application. Now let's talk about the best practices to be followed while configuring these properties. Let's start with the last one, which is, validate connection SQL. So we should add a validation SQL to enable connection validation. It ensures connections in the pool are tested periodically and they remain healthy. It also quickly detects and logs database failures, allowing administrator to take action immediately. So we should choose the best validation method available. We can use a metadata query or we can use a table query. And when we have done sufficient testing and we are pretty sure that there are no issues with our connection pool, and then if we turn this property off, we will get some more additional performance boost. Initially, we cannot turn it off because it helps us monitor our connection pool. But when we are, pretty much satisfied and confident, then we don't need this property. If we switch it off, we'll get an additional boost as well. So a very simple validation query can be select one. If you simply do this, it will run this query periodically on your connections to ensure all of them remain healthy. Let's talk about maximum pool size. So we should tune the maximum pool size to be sufficient for the number of users using the application. It is necessary to handle unusual loads. Similarly, for minimum pool size, we should tune the minimum pool size to suit the application load. If multiple application servers connect to the same database, having a sufficient minimum pool size ensures reserved DB connections are available for all the applications. Then comes blocking timeout. We should configure the blocking timeout in milliseconds so that the connection request wait for a connection to become available until this timeout without, waiting indefinitely. Okay. So a very rational value for this can be 3 seconds or up to a maximum of 5 seconds. A request should wait for an actual connection. This is, blocking timeout. If, this time limit exceeds, we will get a connection timeout exception. Then comes idle timeout. We should set the ideal timeout to the value that suits our application. For a shared database, a lower idle timeout can make idle connections available for other applications. And a higher value for it can prevent the creation of frequent connections for a dedicated database. Now comes a very important point. How should we tune our thread pool? So we can use load or stress testing to eliminate minimum and maximum pool sizes. A commonly used formula to estimate a pool size is connections is equal to 2 multiplied by the core count, means the number of cores in your machine, plus the number of disks available on your machine. This formula provides a starting point, But requirement might differ based on IO blocking and other factors in your system. So reiterating, we should start with a small pool size and gradually increase it based on testing. There is a monitoring tool available which is called pgstat activity. It can help you determine if connections are idling too much, and then you can appropriately reduce the connection pool size. Now let's talk about transaction isolation level. We should choose the best performing isolation level that meets concurrency and consistency needs. Avoid specifying the isolation level unless necessary. And if you specify, set the isolation level guarantee property to false for the applications that do not change the isolation level programmatically. So if it is necessary to set the isolation level, we should set it as transaction read committed. So in conclusion, correctly sizing your database pool is essential for optimal performance and resource utilization. By understanding the factors that influence connection pool size and by following best practices for tuning and monitoring, you can ensure healthy database connectivity and improved application performance. So always remember, start with a reasonable number of connections and adjust based on real world usage and your testing. So friends, I hope you would have liked this brief overview about the JDBC connection pool. We'll continue to bring you more and more videos related to Java and other topics. Please show your love by liking this video and subscribing to our channel. And please tell us in the comment section what more do you want to see from us. Thanks a lot for watching.